Hello learners, this is Education Online program. With you is teacher Rose Hezekiah, and I'm hereby to present for you a lesson in chemistry for senior 1 and 2. Our topic for today is a continuation of the periodic table. In the periodic table specifically, we are going to look at properties of metals, non-metals, and metalloids, and then uses of period 2 elements and their compounds. As you can see, this is an example of a periodic table. The periodic table, as I mentioned before, I said the periodic table is made up of groups. That is the vertical columns, and the groups starts from group 1 up to group 8. Then we have the periods from period 1, and the periods are the horizontal rows from period 1 up to period 7. The arrangement of elements in the periodic table, all the elements fall within 3 categories. They are either metals, then we have non-metals, and then the metalloids. The metalloids shows both properties of metals and non-metals. So we start by the metals. The metals are found at the left hand side of the periodic table, and mostly they represent members of group 1 and 2. So let us look at the properties of metals. The metals are found at the left side of the periodic table, while the non-metals are at the right hand side of the periodic table. When we come to properties of metals, 1, all metals are excellent conductors of electricity, good conductors of electricity, which means that they can conduct electricity. All metals can conduct electricity. Then this electrical conductivity, this is the only property that distinguishes metals from non-metals. We have some metals. Property number 2, we have some metals like manganese, are brittle. So when we look at this table, this is where we find manganese. So we have elements in the middle of the table. So manganese is in period 4, and manganese is a transitional element. Then we have metals. Number 3, we have metals such as gold. We have metals such as gold and copper. Metals such as gold and copper, they are malleable. And ductile. They are malleable and ductile. That is, you can squeeze them. They are malleable and ductile. You can squeeze them into a wire. By ductile here we mean you can squeeze them into a wire, like iron, for example. Iron can be squeezed to give us electrical wires. And And then malleable means they can be hammered. You can beat them to give you, or you roll them into different sheets. Like gold, for example. We use gold to make different, gold can be hammered to give us ornaments. Women usually use gold for decoration, like accessories. And then also they can be rolled into sheets, to different sheets. Like we have zinc sheet, okay? Iron sheets, okay? So these are the properties of metals. We say they are good conductors of electricity, and this is the only property that we can differentiate metals from non-metals. Some of them are brittle, like manganese, and then metals like gold and copper are malleable. We can squeeze them into wires. Like copper wires, we have copper wires, and then they are ductile. They can be hammered or beaten to give us different styles. Then when we come to non-metals, we look at the properties of non-metals. Non-metals are poor conductors of heat and electricity. Non-metals, one, they are poor conductors of heat and poor conductors of electricity. They are poor conductors of electricity. Then poor conductor of heat and electricity. Non-metals, we find them at the right hand side of the periodic table. Specifically starting from group 7, group 5, 6, and 7. For example, we have solid non-metals. We have solid non-metals. Solid non-metals, which include carbon, phosphorus, sulfur, iodine, and then selenium. These are solid non-metals, and then they are brittle at room temperature. That is, they are not flexible. You can break them easily. So these are the properties of non-metals. They are poor conductors of heat and electricity. This means that they cannot conduct electricity, or they cannot transfer heat from one body to another. Then we have the solid non-metals such as carbon, phosphorus, sulfur, iodine, selenium. They are brittle, they are not flexible, they can be easily broken. So non-metals are found at the right hand side of the periodic table. Mostly they fall between group 5 and 7. Then number 3, we have the metalloids. That shows dual characters. They behave as metals and non-metals as well. We have the metalloids. So we have metalloids. Example of metalloids, we have boron, silicon, then germanium, then we have arsenic, antimony, then we have tellurium, polonium, and then astatine. So when we have a glance at the periodic table, we start by boron. This is a metalloid. Then we come to silicon, we come to germanium, then we have arsenic, antimony, then we have tellurium, then we have polonium, this one, then we have astatine. So they are around this area here. These elements are called metalloids because they show dual properties. They behave as metals and as non-metals at the same time. So metalloids are found in the periodic table between the metals and the non-metals. So if we have the metals at the left-hand side of the periodic table and then the non-metals at the right-hand side, so they fall in between the metals and the non-metals, starting by boron. Then let us look at the properties of metalloid. All metalloids are solid at room temperature. All metalloids are solids at room temperature. So at normal temperature, they exist as solid. Then metalloids are less malleable than metals, but not as brittle as non-metals. They are less malleable compared to metals, and not as brittle as non-metals. So they are less brittle compared to non-metals, and also they are less malleable compared to metals. So metalloids tend to be semiconductors. They are semiconductors, which means they can conduct electricity but not as perfect as the metals. They can conduct electricity, but they are not perfect as non-metals. So this is all about the properties of metals, non-metals, and metalloids. As I said in the beginning, I said all the elements in the periodic table fall within three categories. They are either metals or non-metals, and the metals we find them at the left-hand side of the periodic table, while the non-metals we get them at the right-hand side of the periodic table. Then we get the metalloids in the middle. Then let us look at the uses of period 2 elements and their compounds. As I mentioned from the beginning, I said the whole of the periodic table is arranged in a way that we have groups, that is representing the vertical columns, starting from group 1 up to group 8. Then we have the horizontal rows, which represent periods. And the periods we have from period 1 up to period 7. And elements are placed in the periods based on the number of energy level an element has. So we are going to look at the uses of elements of period 2. And elements of period 2 are, we have lithium, beryllium, then we come to boron, carbon, nitrogen, oxygen, fluorine, and neon. All these are members of period 2. And all of them have got 2 energy levels. That's why they belong to period 2. So let us look at their uses. We start by lithium. That is the first member of period 2. Let us look at the uses of lithium. So, lithium is used as additive in, it is used as, we start by lithium as first member of period 2. Lithium, it is used as additive in lubricants. It is used as additive in lubricants in automobile industries. Like we have the lubricating oils. Into auto industries, high voltage and lightweight batteries. We also find them in lithium is found in batteries that are used for cameras. Then also it is used for making strong light alloys. And an alloy is a mixture of 2 metals mixed or combined together to give us a different substance. An alloy is a solid or liquid mixture of 2 or more metals, and the alloy is usually different from the 2 starting elements that combine together. So lithium is used in alloys, in making alloys. And these alloys is used in space. Then we have isotopes of lithium hydride. We have isotopes of lithium hydride. Is used in thermonuclear bombs. Isotopes of lithium hydride is used in thermonuclear bombs. Then after lithium, we come to the second member of period 2 is beryllium. Beryllium is used in X-ray tube. Beryllium is used in X-ray tube to make alloys for springs and gears. So it is used in, we have beryllium. Beryllium is used in X-ray tubes. And all of us know what X-ray is, in X-ray tubes. Then we have member number 3, we have boron. The third member of period 2 elements, we have boron. Compounds of borons are used as cleaning agent. We have compounds of boron. For example, we have what we call borax. This is used as cleaning agent. Then we come to carbon. After boron, we have carbon. And carbon is one of the primary elements that we find it widely in the molecules of our life, in our bodies. So it is the second most abundant element in the human body. The most second abundant element in the human body, that is carbon. We find it in most of the molecules in our tissues. First, it enters into formation of it forms the skeleton of all organic compounds. It forms the skeleton of all organic compounds. And of course, organic compounds are compounds of carbon and hydrogen, mostly form of carbon. So the skeleton of organic compounds is made up of carbon atoms. Then graphite is used. Graphite is a compound of carbon, the black material. Graphite is used as lubricant to make strong structural fiber in steel making. We find graphite in pencils. Also, we can see graphite in batteries. What is called the lead accumulator. And then also carbon enters in manufacturing of plastics. Manufacturing of plastics. And then we have also diamond. Diamond contains carbon. Diamond is a carbon compound. Diamond, we all know that diamond is one of the most expensive and precious we call it minerals, and then it is used for jewelry. It is used for jewelry. Also, carbon is used for making protective films. Protective films. So as I said, it is the second most abundant element in human body. Then we have nitrogen. Nitrogen is one of the primary element in molecules of life also. Especially we find nitrogen in proteins. It is one of the elements that is in structures of proteins. And we know how important is proteins to the human body. It is for body building. If in proteins, and then we have nucleic acids. The presence of nitrogen is there. It is used in the manufacture of ammonia. It is also there in fertilizers. And then explosive. It is used in explosives, rocket fuel, and then we have as an inert blanket for electronic equipment. It is used as an inert, that is an unreactive blanket for electronic equipment. That is for covering electronic equipments. This is all the uses of nitrogen. Then beside nitrogen we have oxygen. Oxygen is the most abundant one. So oxygen is the most abundant element in the earth crust, followed by carbon. So oxygen is a gas that is essential for our life. Without oxygen we cannot survive. So it is the most abundant element in the earth crust. It is a gas that is essential for life. We breathe in. Then it is needed for combustion. Oxygen is needed for combustion, that is for burning. It is used in water purification. It is used in water purification. And then it is also used in steel production. It is used in steel production. Water is, we know that water is a compound of hydrogen and oxygen. Water is a compound of hydrogen and oxygen. This is water. So 88.9% of water is oxygen. And we know that water is one of the most essential substances for life. Then we have fluorine compounds. Fluorine is the second to the last before neon. We have fluorine. Fluorine is used as additives in toothpaste. It is used as additives in, when you look at the components of toothpaste, you get fluorine is there. It is used as additive in toothpaste. It is used in uranium enrichment. It is also used in for making Teflon. It is used for making Teflon. Then we have the chlorofluorocarbon compounds, CFC. The chlorofluorocarbon compound, CFC. It is used as a refrigerant. It is used in the refrigerator. Chlorofluorocarbon compounds or carbofluorocompounds. It is used as a refrigerant in refrigerators. Then also we have the last member of period 2 is neon. Neon is used in elemental enlightening. We get them in some of the electrical bulbs. It is also used in neon lightening for advertising signs. We can get it in TV and monitor tubes, laser, and then voltage detectors. So neon is mostly found in electrical equipments. So these are all uses of members of period 2, starting from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Sorry. So dear learners, we have come to the end of our lesson. Thank you for listening. See you in the next lesson. Bye bye.